Right. So today topic is intramolecular aldol condensation reactions. So it's a very important topic and applications of aldol condensation reactions. Right. So generally where they are asking the questions that intramolecular means. So generally we are taking for JE mains and JE advanced. Generally they'll make the questions on intramolecular aldol condensation reactions. Right. So generally intra. So intra means within the molecules, right? So which molecules gives this type of reaction means like diketones. So this reaction is given by like diketones. The molecule contains diketones. So diketone means the ketone position should be, which position means like 2 comma 5 position, and the keto group should be 2 comma 6 and 2 comma 7 and 2 comma 8. So molecule contains keto groups at 2 comma 5 position, 2 comma 6, 2 comma 7 and 2 comma 8. So that type of diketones gives intramolecular aldol condensation reactions, right? And what is the another case? If you go for second one is aldehyde and ketones. We can go for one is aldehyde functional group, and one more functional group is keto functional groups. So one aldehyde, one keto functional groups, this type of molecule also gives intramolecular aldol. And third case is both are aldehyde groups, both aldehyde functional groups. So aldehyde functional groups, both are aldehyde functional groups. So this type of molecules gives intramolecular aldol condensations. But all diketones and aldehyde and keto molecules and both aldehyde functional groups, so doesn't gives aldol condensations. But position should be very important. If you give diketones, so 2 comma 5 keto functional groups and 2 comma 6 position keto functional groups and 2 comma 7 keto functional group and 2 comma 8 keto functional groups. So let us take one simple example for 2 comma 5, right? If you go for 2 comma 5, so 2 comma 5 means I'm taking one simple example, CH3, right? And here is C double bond O, right? Here is CH2 and CH2, and here is CH2, here is C double bond O. You can take it, here is methyl group, right? Now check the position of keto functional groups. We have to assign the numbering 1, 2, 3, the 4, the 5, it is a 6, it is a 7. So here position should be which position? 2 comma 6, right? If you go for 2 comma 5 means I can go for replace this one. Here is methyl group, we have to keep it like double bond O, and here is CH3. Now we can go for the position of the functional groups here. So what is the position of the functional group? 1, 2, 3, 4, 5, 6. So it is the position of keto group is 2 comma 5. Similarly, if you go for 2 comma 6 means CH3, C double bond O, CH2, CH2, right? Here is CH2, C double bond O, CH3. So I taken one more example for this. We have to go for the numbering any one side, 1, 2, 3, 4, 5, 6, 7. So it is a diketone. It is an example for the position of keto groups is 2 comma 6 positions. So 2 comma 5 and 2 comma 6, right? So if you take 2 comma 5, so where which alpha carbon forms carbon ions? Here. So here is keto group, it is also keto group. So both are symmetrical because of methyl next keto group, methyl and keto group. It is a symmetrical diketones. So in these symmetrical diketones, which carbon is involved in or forms carbon ions, alpha carbon? As suppose I am taking these carbons, it is alpha carbon, it is also alpha carbons. So which alpha carbon forms carbon ions or enolate ion for to get stability, or carbon ion means this alpha carbon. Suppose if it forms this carbon, alpha carbon forms carbon ion means it is joined to this group. So total 1, 2, 3. It is a 3-membered ring. So 3-membered ring is unstable. So generally intramolecular aldol condensation reactions generally utilize it for to make 5-membered and 6-membered rings. 5 or 6-membered rings. So formation of 5 and 6-membered rings by using intramolecular aldol condensation. It's the best convenient method to prepare 6-member ring and 5-member ring because they are more stable. If you go for 3-member ring, if you go for this carbon ion added to this carbonyl carbon and partial positive carbonyl or electrophilic center, it forms 3-membered. It is a more steric strain. That's why it doesn't exist. That's why 2 comma 5 and 2 comma 6 outside alpha carbons, not inner alpha carbon. We are taking the outer alpha carbons forms carbon ions. So carbon ion means here acidic hydrogen is joined to oxygen atoms, more electronegative element, partial negative, and the carbon ion negative charge is added to here. So what the product will be formed here? Now we can expect for this 1, 2, 3, 4, 5. It's a 5-membered ring. So directly we can make the 5-membered ring in cyclic form. First make that 5-membered ring. For example, this methyl group is carbon ion. This, for example, this is the carbon ion CH2 group joined to C double bond. So this double bond is joined means what we are getting? Here single bond O and here is hydrogens. So this methyl group is joined to this carbon means it is joined to one more group is there. What is which group is there? It is a methyl group. It's a side chain. Just you can go for CH3. Right? So here methyl group is joined to this carbon means where we are getting that double bond over here. So here methyl group joined to this group. So methyl group is joined to here means here. So here adjacent is here we are getting the keto functional groups. Right? So it is alpha, it is beta. So beta hydroxy keto functional group is formed. It is called aldol product. Right? What are the aldol condensations? If you go for stability purpose, you have to go for acidic, medium, and delta. So we are getting that condensation product. Because of condensation products are more stable than aldol products. Because of here OH group, here is alpha carbons, alpha hydrogens. Both are eliminated to form here double bond. Here is methyl group. Here is the double bond. Here double bond is conjugation with keto group. So it exhibits a resonance to get the more stables. So this is the major product. Right? So major product is this is the major product. This is the 5-membered ring is the major product. If you go for 2 comma 6, so which carbon, which alpha carbon make carbon ions? We have to check it here. 1, 2, 3, 4, 5, 6, and 7. Right? Just you can think it out. It is a symmetrical ketone, diketone. Symmetrical means methyl. CH, C double bond here also methyl and C double bond. It is a symmetrical diketones. If you take symmetrical diketones, which carbon forms alpha carbon forms carbon ions? Right? First check it in inner side. So it is the inner alpha carbon and it is the outer alpha carbon. If you take inner alpha carbons forms carbon ion and H plus acidic hydrogen is joined here means. So what is the problem of here? 1, 2, 3, 4. It is a 4-membered ring. So 4-membered ring is unstable. So that's why we have to go for outside alpha carbons. So this addition is wrong. We have to go for outside alpha carbons. So here also 2 comma 6 diketone. Also we are taking that outside alpha carbon forms carbon ions. This one. So hydrogen acidic hydrogen is added to that carbonyl oxygens, partial negative. It gets a partially positive, and carbon ion is added to the carbonyl carbons. It's electrophilic center and it's a nucleophile. So H plus is added here. Carbon ion is 1, 2, 3, 4, 5, 6-membered. So we have to make the 6-membered ring like cyclohex, the 6-membered ring. Here is methyl group is carbon ion means I am taking for this point is a methyl carbon. Methyl group is joined to this carbonyl carbon means oxidation is means pi bond is breakdown. So OH group. And this one is added to the side chain is methyl group is there. Just write the methyl group. So don't confuse here. How to make ring formation? After ring formation, where is the branches? That means side chains. We have to go for make that side chain, right? It is a substituent methyl group. And where ketone is there, the methyl group is joined to this one means the methyl group is joined means adjacent is keto group is there. We have to write the here is keto group. Right? It is a aldol product, intra-aldol product. So followed by elimination. So we are getting that here is OH, it is alpha carbon, it is a beta. So alpha beta. So but which hydrogen is eliminated? Here also alpha carbon. If you go for this side is OH group, this side also a hydrogen is there. So both the sides hydrogens are there. But which alpha hydrogen is eliminated to form pi bond or double bond means. So this side, this alpha carbon is eliminated because of keto group is major functional group. Alpha hydrogen is eliminated to form conjugated product will be formed. So conjugated means double bond here and double bond here. We are getting that methyl group. So this is the major product. Right? If you do inner means six, five, or four membered ring. If you go for outside means it's a six membered ring. Four membered and six membered. Which one is stable? So generally in aldol, intra-aldol condensation reactions, so which rings are can form and since the five membered and six membered rings are more stable. That's why we have to check with first five membered. If five membered is possibilities are there, we can go for allow for the five members. Right? Otherwise, you can go for the six membered. Here, intra means if you go for inner alpha carbon means four membered, outer mean six membered. So four and six, which one is more stable? Means six membered is more stable. If you go for 2, 5 position, intra aldol means which one is more stable? If you go for inner alpha carbon forms carbanion, it is a three membered, it is unstable. That's why you can go for outer alpha carbon is involved to form five membered. So five membered product and six membered products are more stable. So in aldol condensation reactions. So here 2 comma 6 and 2 comma 5 diketones which carbon forms carbanion means outer alpha carbons, not inners. It's the inner, it is outer. So outer alpha carbon forms carbanions. It added to the electrophilic center. It's a carbonyl group, another carbonyl group. Right? It is a one case.